What is multiplication? At early to first level, we begin by skip counting doubles and repeated addition, and we'll explain that in more detail in just a moment. Children complete practical activities with concrete materials. They may sing songs and they may play games. When we feel the pupils are secure in their knowledge of counting to 20 and 100 and counting to those from any point, then we feel they have the good foundation to begin skipping numbers. So what we mean by skipping is just missing them out. So instead of saying 1, 2, 3, 4, 5, 6, we would simply miss out each other number. So 2, 4, 6. And that's where things like songs would come in as well. Pupils then learn how to double numbers, and this is a foundation of the 2 times table and even to divide by 2 if you think about finding halves. We investigate number sequences, initially those increasing and decreasing by 2s, then 3s, 5s and 10s, and this can be from any starting point. So it may not simply be the example underneath we've got here, counting up in 3s and starting at 0. We may ask them to start at 7 or 13 so that they've got that practice of making those jumps. It also helps with early addition. We still encourage the use of practical materials like cubes and number lines. So if you were finding out 6 times 3, you would make those jumps at first level. We also look to materials for counting up in 2s and even some patterns. So here we have an example with Numicon. You may have seen that in the school. All the Numicon pieces have a value, and those values represent the shape and size. The one in the middle here, 3 plus 3, equals 6. That's what those pieces of Numicon look like. But also, the 3 and the 3 piece fit perfectly on top of the 6, so that you can identify straight away what that answer is. 4 and 4, when we put those two together, they make an 8. So this helps the children to discover it for themselves. We also play games. Dominoes are a really popular one, and I would encourage anyone to use that at home to help with doubles. We also look for patterns in our counting. When counting in 5s, the answers will either end in 0 or 5. So if you have an answer that doesn't end in 0 or 5, you know that that's not correct. The same with counting in 10s. It will end in 0. Then we move on to something a wee bit more tricky. So once they are comfortable with the stations of the 2 times table, we begin to look at the pattern and the relationship between the 2 and the 4 times table. So as you may be able to notice, it simply doubles. 2 becomes 4, 4 becomes 8. So if you know your 2 times table, you can work out the 4 and then the 8, because again, it's doubles. We also use different words. So 3 times 7 could also be 3 lots of 7, 3 sets of 7, 3 multiplied by 7. It's important for the children to understand that they may be asked different types of questions, but that actually it's still the same question. We begin to look at groups of amounts, and I'll show you that just now. So this is a visual representation of the question 4 times 5. The children can count that up using addition, or they can begin to count in 5s, as we were speaking about earlier with the skip counting. It's really important for children to see the visual aspect here, because we want them to understand where that question comes from and where that answer comes from. It's not something that's just rote learning. We're giving them the foundations with that visual representation. And here we have another one. We're talking about equal numbers in each group, and then that way we can just simply count up. So rather than count every single one, at this point we'd start to encourage the children to use that skip counting. Now here you can see it's 3 times 5, but the children could count up in 5s, and we'll talk about that law in a wee moment. We also use arrays. This could include counters, cubes, or even drawing some. And again, it's about a visual representation. So here we have 3 rows and 3 columns, which would be 3 times 3. We have 3 rows and we also have 4 columns. So that would be 4 times 3 or 3 times 4, and we will speak about that again in a moment. We have some more here. And here we have one written out with that addition, as we mentioned earlier. So multiplication at the beginnings may be done through addition, so that they understand that 3 times 4, 3 lots of 4, we're talking about 4 plus 4 plus 4. We want them to begin to see this foundation rather than simply rote learning. So as I mentioned earlier, we have the commutative law, which is 4 times 2 is the same as 2 times 4, and 6 times 3 is the same as 3 times 6. It's really important for the children to understand that they can swap those around and still have the same answer. For some children, the 2 times table is easier than the 4, and the same with 6 and 3. So we want to encourage them to use any strategy they can. We go back to doubles for 8 times 6. Double 6, so 2 times 6 is 12. Double that again, so 4 times 6 is 24. Double again, 8 times 6 is 48. Now that strategy may be one that your child enjoys using, but again, it may not suit their style of learning. We also use songs, chanting and other methods to help us remember the times tables. But we want to encourage them to use strategies and find ways of working out the answer if they can't remember. We have some other patterns here. And over here, we have some questions that begin with the answer. And it's really important for children to be exposed to that, because what we've found is that children see it as being the question, then the answer, and that doesn't always necessarily is the case. So we encourage children to approach it in different ways. We also encourage them to see the relationship between division and multiplication, because it's important that they see that they're all linked when they're working out their answers. First, going into second level is still about patterns and relationships. Let's look at 2 times 3. So, straight away, we know that relationship with division. 6 divided by 3 is 2. We spoke about doubles earlier. 2 times 3 is the same as 4 times 3. Then we begin to go to larger numbers. 2 times 3, if that's 6, what would 20 times 3 be? Well, you're multiplying the tens column as there's 0 in the units. This will help them to see those patterns. Again, with the hundreds. We've got another one here. We've worked out 20 times 3, so we use our doubles to work out 40 times 3. And then we have some more difficult ones, like BODMAS. So we've got some bracket work here. But the children will still understand the relationship because they know that 2 times 3 is 6. So if they know their doubles, they'll know that 4 times 3 is 12. And when they're finding a half, which again is related to their doubles, it's 6. So although that looks like a complex question, it's rooted in their foundations from early on. Okay, so let's look at a larger number, 364 times 3. We may not initially show them how to do this as a vertical sum, a chimney sum. So what we really want them to do is to be able to work that out mentally. So instead of simply taking it as a big number, we break it up into smaller pieces. So let's see how we could break it up. Well, the simplest way would be to break it up into the hundreds, tens and the units. And we multiply each section by 3. So we would start with 300 times 3. Well, we would know 3 times 3, and we would use that link to help us find 900. Then we've got 60 times 3, and we would use that link of 6 times 3 to find 180. Then lastly, 4 times 3. Once we've found those elements, we add them all together. And you can see it's a much quicker sum and a much easier way of doing this mentally by breaking it all up into pieces. It also gives the children a greater understanding of what that number really is. They give them that number sense, that 364, what is it made up of? So by being able to break it into smaller pieces, we know that they have understanding that it's not just digits 364, it's worth 3 hundreds, 6 tens and 4 units. This is a second method that we could use, and this one's called the grid method. So the pupils start off by drawing a grid, and this question again is the same as earlier. We're still trying to find out a larger number. So it would be 35 times 6. So again, we're going to break the number. That's also called partitioning. So we've partitioned the number at the top. We've broken it into 30 and 5 in the same way we did the previous one. And then we know we're going to multiply them both by 6. So again, we go back to those initial ones, 6 times 3. We know that that would help us to work that one out. And it would also help us to work out 6 times 5. So we'll multiply both 30 and 5 separately. 60 times 3 is the same as 6 times 3. And then we add it all together. So we're breaking it up into pieces. So 6 times 3 we know is 18. So 6 times 30 is 180. And 6 times 5 is 30. So we're taking 180 and we're adding it to 30. More complex questions, such as 52 times 38. We're still breaking the number up again. So we're breaking it up into the 50 and the 2 and the 30 and the 8, and we're multiplying each of those numbers. We're multiplying both 50 and 2 separately, so 30 times 50 and 30 times 2. Well, we would go back to our 3 times 5 again, and we would go back to our 3 times 2, and that would help us find 1560. Then we would multiply 8 times 50 and 8 times 2. So again, that would give us our 400 and our 16. And then lastly, it would be an addition sum. We would encourage children to do this mentally rather than a vertical sum, but if they need that strategy, that is always there for them. Again, use of partitioning helps them have a greater understanding of what those numbers mean. Multiplying decimals. We have another strategy here. We may draw out the hundreds, tens and units, and then the decimal point and tenths and hundredths. At this stage, it's very important to highlight we do not move the decimal point. It's the digits that move, and you can see that in this example. So the 6 moves into the tens column, because when you multiply 6 by 10, you get 60, which is 6 tens. The 7 tenths would be 0.7. When you multiply 0.7 by 10, you get 7 ones or 7 units. Both of those pieces of language are correct, so if you hear the children refer to it as ones instead of units, it's exactly the same. And we do not mind at this stage the language that they use, as long as they're understanding what the pieces are worth and how to follow this strategy. And then we would look to the hundredths, which would be 0.04 times by 10, so we know that that becomes 4 tenths. The children usually use this as almost a shortcut, because they know by multiplying by 10, you are moving it one space to the left. Okay, you're moving it one column, the decimal point does not move. And when you're dividing, it's going in the opposite direction. If it's timesing by 100, it would be 2 spaces, and 1,000 would be 3 spaces. But we find that this initially really helps them understand the positioning of this digit and the understanding of what the number really means. So 6.74 is 7 tenths and 4 hundredths. And what would that look like on its own? And it also is important for them to understand they can't simply add a 0 when they are multiplying, because this is an example of why that would not work out. If you had 6.74 times by 10 and you simply added a 0, it would still be 6.74, but with a 0 at the end. Nothing would change. So that's why you may see us using different strategies like this one to multiply by 10, even without decimals, so that they can understand where that 0 has come from. It's not just been simply added on. We'll also encourage them to use mental strategies that we've not covered, and something that perhaps that they use on a frequent basis that perhaps we've not taught, but it still works for them, and that's fine. We also look at formal sums. So this is probably a similar method to how you would have learned in school. So here we have 1,135 multiplied by 6. We would find out straight away that 5 times 6 is 30, and we would put the 0 and then the 3 underneath. Now, if you have been taught to put it below the first 3, and I'll just show you whereabouts that would be on here. So you would be taught to put that 3 here rather than in the basement. It's fine, because that is still learning the same strategy. Then we would do 6 times 3, and we would add on that additional 3. So here we have it here. Okay, and we would still continue to do that, adding those pieces on. So I think you'll find that the written method is quite similar to the way that you have been taught. We prefer children to have a very good understanding of what these numbers mean and what's being asked of them before we go on to sums. So you may find that they're doing a lot of practical activities before that they're ready for this. We believe the journey between concrete, visual and abstract, which means using cubes, and then visual, maybe drawing the picture out or using a strategy like the boxing up strategy, or lastly going on to the abstract, which is your sums, is a journey that they may go back and forth with. So you're not to worry if they have to use strategies initially before they're ready to use those sums. We would do more complex formal sums as well, like 52 times 8. And you can see that how we've broken that down. You may have your own method of doing multiplication, and we would love to hear it. Why not send us your own video clip? Write down your method and send it to your child's teacher. Email your strategy. Thank you for listening.